Okay, we're asked to, oh, I forgot what I was asked to do. What was I asked to do? Oh, just simplify this. And we want it in rectangular form. So when I look at this, I could multiply that out 8 times with FOIL. That sounds god-awful. Now, there are some, if they give you like a square, it's actually easier to use it. But instead, what we're going to use is we're going to use our cool new formula, which means we need to convert this to trig form first. So this is an example of when this really is going to save us a lot of time. So I'm going to start by drawing my picture. And so I go over the square root of 2 over 2, and I go down the square root of 2 over 2, because remember, this is my x and this is my y. So here's my triangle. There's going to be my theta. And then so r squared, this one out here, is going to be the square root of 2 over 2 squared plus the square root of 2 squared, which is going to give me, let's see here, 2 over 4 plus 2 over 4, which is 1. So then r is 1. Okay, now I need to figure out, so then the tangent of theta is going to be the square root of 2 over 2 over negative the square root of 2 over 2, or, well, one of those is positive, or negative 1. Okay, you can put that in your calculator. You can know that. Theta is 315. This is actually one of your special angles. This is something you could simply get off the unit circle. If you put in your calculator, you will get negative 45, but we need to be in the fourth quadrant, which negative 45 is. We just prefer the 315. So then, our trig form of what we were given is 1 CIS 315 to the 8th. So at this point, all we've done is we've rewritten the rectangular coordinate into polar, into our trig form. Now we're going to use our cool new thing. So this says 1 to the 8th is 1 CIS, and then 315 times 8 is 2,520. Okay, so then I come out and I do the cosine of 2520 plus I, the sine of 2520. Okay, just put those in your calculator. You should get a 1 here. You're going to get a 0 here, which means this whole thing is 1. And those are just, make sure you're in degrees, plug them into your calculator. You could do these by hand if you start subtracting 360 coterminal angles until you get back to the regular unit circle. They're on there. It's just they're so big that let your calculator do the heavy lifting. But this is an example of when this theorem can really save us some time and why you'd want to rewrite it that way versus simply doing the algebra.